Good morning. Today we're going to talk about AWS Spot instances. I just want to feel the audience. Is a lot of you using AWS? Can you raise your hand, please? Okay, like half of. So we're going to talk about serious things, not in a very serious way. Does it work? Yep. So this presentation going to be R-rated, so it's restricted. So keep an eye on your managers because we're going to have a strong language like savings, pay less, and reduce your AWS bills. So this could be very dangerous in your company when the manager sees this without supervision and comes to you next day like, I want to spot instances. So it's not that easy. Let me talk about myself for a bit. So my name is Taras. I'm from Lviv, Ukraine. Here you can see picture from different conferences. You can see boosting confidence level. If you see me speaking on other conference, then probably seeing that I'm a good speaker. So I'm from Ukraine, Lviv, but I'm working for a Dutch company called Get Social. So as Get Social, we provide a SaaS platform for mobile application. So basically, we have an SDK which you can put into your app or mobile game, and you have tons of different social features like invites, referral links, social graph, tons of analytics, all the stuff. So sometimes I do public speaking, not too much, but probably as you can see me here, then sometimes I really do. And I do open source. Like, I love to contribute into different projects. My favorite language is Golang, and I'm very happy that most of the tools now being developed in Golang, so I'm happy to contribute in them. Also, if you heard about Google Developers Group, so I'm like co-organizer in my home city. We do small events about cloud and other stuff. I do love internet and cartoons, and this is important because I have a tradition. Most of my presentations are made in cartoon style, and this one is no exception. And so here's my GitHub, LinkedIn. Probably you don't care about that, but if you want to check it out, go ahead. So this presentation is going to be made in the style of cartoon called Over the Garden Wall. Is somebody see it here? Oh, one person, 2 persons. So after the conference, like, it's only 10 episodes, 10 minutes each. You should check it out. But it's not important that you didn't see it. And it will have some symbolism in it. So here we can see some characters. So this is the beast. It's going to represent everything scary that we can see in our AWS account, probably the billing page. So, and all the actions happen in the unknown. Like this is some mystery place, unknown. It's because like with the Spot instance, we don't know what will happen next. So we are going to be in the unknown. And this is the boys, Greg and Wirt. It's going to be us, trying to survive in the hostile environment. And so welcome to the unknown. You may be lost more than you realize. This is a quote from the cartoon itself. This is a woodman told to the guys. Let's go next. So our agenda for today is we're going to talk about what different purchase options on AWS we have for the EC2, Spot instances integration with different services and auto-scaling group. With examples, I'm going to tell you a bit how to manage risks and cloud formation examples. Then we're going to talk about ECS and how to integrate it all with ECS, how to plan the capacity, and how to handle the interruptions, and all other stuff, and more examples. So about purchase options. There are a couple of them. Actually, there are more of them. If you go to the documentation, probably 10 of them. But we're going to talk about only some of them and detail only about Spot instances. So there's the on-demand. On-demand is the one that we use by default. Like this is per second billing or per minute. And you just launch the instance and you pay the static price for every minute you use it. Then there's reserved instances. Reserved instances are pretty cool, but it doesn't have the flexibility we need sometimes. With the reserved instances, we need to purchase them upfront, with upfront payment or without, but we commit to use this instance for a year or 3 years. And AWS gives us a huge, not a huge, but big discount. So it's you're going to pay much less, but you need to commit that you're going to use this instance, and then you need to keep track that you're really using the instances you committed to, because you're going to pay for them anyway. And the last one is the Spot instances, the one we're going to talk about today. Like, how many people know what the Spot instances is? And is somebody using them? Nah, cool. Maybe you will start after this talk. So Spot instances is actually the way to utilize the unused resources that AWS has. Like you can imagine, they have huge data centers, and they cannot utilize it all. They always have spare capacity for future clients. So they're trying to utilize this capacity as much as possible. So they invented the Spot instances, which basically you can rent for much lower price, and they say like up to 90%. So basically, this is a huge savings for your company. Here you can see the graph. What we're going to do this way. It matches the style of our presentation a bit more. And probably everybody likes the dark mode nowadays, so let's use it here. So this page is actually pricing history. You can see it on AWS console, and it says the price for Spot instances over the time. So we can pick instance type here. For our example, it will be M5 large. And we can see the on-demand price for it here. So this is the default price that we pay for on-demand instance, so like almost 10 cents. So, and here, this is the line on the graph. This is the on-demand price. It's static always. And this is the spot price. The spot price differs per availability zone. And this is the spot price over time. So basically, you can see it's fluctuates, but it's almost 2 times cheaper. It depends from the on-demand price. So that's cool. Keep attention. This is my most favorite slide. So spot instances are cheaper. And this is a rock fact. So they're cheaper. So what's up? There should be a trick. Like AWS not going to give you 90% for instances just for fun. And the catch is the Spot instances can be interrupted by EC2 when they need it back. So at any point, AWS is going to take instances back from you, and they're going to notify you 2 minutes before. But that's not completely true. They could not. They may notify you or may not. Things happen. So what does it mean? That you have instances with huge discount, but anytime they can go down, and you need to be ready for that. AWS can take them, and they don't care. But you pay much. You get a big discounts for that. So what do you need to do? We need to handle the risks. We need to be prepared for our applications that one of the servers go down and even more servers can go down. We need to fight with the beast to get our application healthy and ready. And there are different ways to use Spot instances. Fortunately, over the last 5 years, it becomes more and more easy to launch and manage them. So the first way is called spotinst.com, and does anybody knows what's that? Yeah, that's external service that can launch Spot instances for you. They claim that they use data science to predict when the instances are going to go down. Also, you're not paying them. They're just taking 20% of the cost savings they generated for you. That's quite nice. But all of the features, all of the auto-scaling group, etc., are built custom by them. So basically, you're not using AWS code. You're using Spot inst code. And they manage your servers for you. And I don't really trust them. Like, I have trust issues with companies who manage my servers. This one, and it's appeared in 2015. Then AWS introduced Spot Fleets. Spot Fleets is a pretty cool feature. It actually allows you to request a fleet of EC2 instances that are being launched on the spot. And you can say, basically, I want to have in my fleet 30 CPUs and 25 gigabytes of memory, or 50 gigabytes of memory, and they will pick the Spot instances for you to match this capacity and maintain it. It was improved over the years. They didn't have many features at launch, but now they have tons of features, like auto-scaling, keeping capacity monitoring, and other stuff. And that's one of the easiest way to use the Spot instance. So basically, you go, you say, I want 20 CPU and 50 gigabytes of memory, and they will create these instances for you and try to keep it with this capacity all the time. Even when some of them dies, they will launch a new for you. And the last way is via auto-scaling group. This way was introduced only recently in 2018, and almost 1 year. And what's the beautiful thing about using Spot instances with auto-scaling group, that it actually has all the features that auto-scaling has, like termination hooks and webcycle hooks and scaling policies that you have, and all the activity history of the scaling group. Basically, it's the same auto-scaling group that you was using usually, but now you can do it with Spot. And that's really cool. Like this was, I was waiting for this for a long time. And integration of the auto-scaling group as Spot instances looks like this. So this is a page where you are configuring the Spot instances for auto-scaling group. You can see here that we pick the instances types that we want to have in our auto-scaling group. Here, we set the price that we are willing to pay for Spot instances. So as I said on the graph before, the Spot price can change. So, and we are setting the maximum price that we are willing to pay. And if the actual price breaches this limit, Spot instances will be taken from you. And by default, this setting is set to on-demand value. Basically, what does it mean? That we say we want to run the Spot instances as long as they are cheaper as default instances. And this is good for most cases. But you can set your fixed price, like, I don't want to pay more than 4 cents per hour. And it will try to keep this capacity, but you can set the price too small, and it will never meet any instances with that price. So we need to choose wisely. And also, you can set the launch strategy, basically to optimize it for price, to have a lower price, or for availability. We can take a look there later. And yep, as you've seen here, we have many instances type. Why do we need many instances types? We need many instances types because we don't want to put all the eggs in the same basket. Why so? Let me explain in the next slide. This is for risk management. We need many instances types because, we're going back to the same graph, as I already mentioned, that we have instance type and we have availability zones, and price is different over the time. So combination of instance type and availability zone called instance pool. So basically in this configuration is 5 instance pools. Basically 1 instance type and 5 availability zones. This is also a screenshot from AWS console, but it's actually from the fleet configuration because it's really nicely visualizing the instance pools. So when we're creating a fleet or auto-scaling group, we are specifying many instances types to improve our availability and to handle the risks. Why so? Because, for example, here we specified 6 instance types within 4 availability zones. This means that we are going to have 24 instance pools. And UI said, like, yes, our fleet strength is strong. What does it mean? Basically, for example, if you had 10 EC2 instances, but you launched all of them in the same instance type and the same availability zone, if price for this, basically that would mean that we're launching them into 1 instance pool. If price for this instance pools goes higher than our max price, this will mean that AWS will take down all 10 instances for us. So basically, it will kill our application at once. But if we created 24 instance pools, then price changes per instance pool, and there is very low chance that even 2 of the instance pools will have a price surge. So if a different example, if you have the same 10 instances, but within 24 instance pools, and 1 instance pool's price goes spiking, that means that only 1 of 10 instances will go down, or maybe even not. Maybe none of our current 10 instances was in this instance pool, was located in this instance pool. So you can feel the difference. Like within first configuration, price goes high and we're losing our 10 instances. Within this configuration, price goes high and we lose 1 instance. And it's going to be replaced in a couple moments. But it's not that bad. Basically, this is a screenshot from my production AWS account. And you can see that I have instances that are running for 5 months straight, and it was not interrupted. So in half a year, nothing happened. You still need to have all the stuff in place to be prepared for interruption, but it doesn't mean that it's going to happen every 10 minutes. it could take half a year to kill the server. Why price could go high? For example, Spot instance is very popular for doing such things like data processing or some machine learning. You can imagine a huge company who has tons of terabytes of data, and they need to process it. In order to process all of this data, they need to spend a fortune for the servers. So basically, they are waiting for a moment where prices are lowest, for example, Sunday morning, and they request from AWS, I don't know, 10,000 of Spot instances, and start processing all of this data. And since this big company requested all of this instance, then demands go higher, and the price goes higher as well. So what does it mean for you? If you have this instance running with, I don't know, some price limit, pretty sure that this demand will cause a spike of price, and your instance will be taken from you because they are willing to pay for it more, and they need it right now. But this is the link. It's called Spot Instance Advisor. It's a really cool link, and it will show. I can open it actually. Yep, here you can choose the region, for example, US East, and the instance types, and you can sort by savings or frequency of interruption, and you can see how often this instance type is being interrupted. And you can see here that T3 small, T3i micro, and these instance types are interrupted not very often, but if you change to big instance types and basically a specialized one, there's the CPU optimized and their memory optimized. So usually companies use Spot for the instance optimized for processing big amount of data. Like for machine learning, you could have instance with, I don't know, 256 gigabytes of RAM, and they're using this kind of instances. But if you're using the general purpose instances like T2 or M5, they're not really so popular to doing batch processing, so there's a big chance that they're not going to be interrupted. So you can see the interruption chance is less than 5%. And also you can see a savings here. So when you're planning your Spot capacity, the instance types you want to pick, go to this link and find out which one is interrupted the less. This link is very useful. The shame that I found it 2 weeks ago when I was preparing the presentation, not a year ago when I needed it. So use it. Okay, go further. But even if AWS does a great job to integrate Spot instances with many services, they build a really nice UI with really nice tips and explanations how to do it, which instance types to take. It makes sense to use it with CloudFormation. In production, probably you're going to use it with CloudFormation. You're not going to configure it manually. At least I'm not going to. I'm not sure about you. So can you please raise a hand who knows what CloudFormation is and using it? And maybe Terraform? Hey, Terraform more. But we're going to talk about CloudFormation, sorry. And I will explain a bit why. But it's not very strong reason not to use CloudFormation, but it has some benefits. So this is example of CloudFormation template. This is actually example how to launch the auto-scaling group with Spot instances with CloudFormation. And yep, you don't really see it, but I highlighted with the red. Yeah, now you see it. So all of this code, auto-scaling groups, the lowest price, max instance, min instance, we don't really care about that. What I wanted to show for you is this part. It's called overrides, and here you specify what instance type you want to use in your auto-scaling group. And in real life, you wouldn't use template like this. Probably you would want to put this into parameter. So you can reuse the same template for different environments. For example, for testing, you want to have T2 micro, and for production, you want to have, I don't know, M5 large. But the one who used CloudFormation probably know that CloudFormation provides parameters, but they don't provide parameters within complex types. You can provide parameter as list of instances, but you cannot provide parameter in this format, where this is list of objects, and each object has key instance type. So basically, it's very stupid. You created CloudFormation template, you should hard code this. You can't really provide parameters. Provide this as parameter. You can provide there is a stupid way. You could provide parameters instance type 1, instance type 2, instance type 3, and you need to put this manually. But there are no easy way. However, I couldn't agree with that, and I was looking for the way. So there is a hack you can do. So this section called mappings, and CloudFormation allows you to create custom maps of some stuff. In our case, we created a map called instance types and called them Spot Medium, Spot Large. This is custom name. It could be DevTalks1, DevTalks2, code.talks. You create whatever you want here, and you put whatever you want here as well. But what this allows us to do? Then we can use, instead of putting the list of instances here, we can use a function here, find in map, instance type, and here is a parameter. In our parameter dropdown, we will provide our custom instance types like Spot Medium and Spot Large. And for example, for testing, you can use Spot Medium, and for the production, you can use Spot Large. And this will actually put this list on that place. So this is like a small hack which should help you build CloudFormation with the Spot instances. Spot instances with AWS ECS. Now, new questions. Who used AWS ECS? Okay, and EKS? And the same amount. I'm going to talk about ECS because it's what I'm using in production. But actually, there's similar stuff for Kubernetes, which can do automation with the Spot instances. But this is going to be talking about ECS. So for those who don't know, ECS is Elastic Container Service. So basically, you build the Docker container, you push it to AWS, and you says like launch 10 copies of this container for me, and it will place it in the cluster on the available nodes. Like similar as Kubernetes or Docker Swarm, but from AWS. And the main advantage is free. You don't need to pay. You're just paying for nodes in the cluster, but you're not paying for master. You don't need to have control plane like with Kubernetes. And as far as I know, on Amazon EKS, you're paying $150 per month for control plane. So basically, if you have 2 clusters, it's already $300 per month. So ECS is a bit less flexible than Kubernetes, but it is much simpler and cheaper. So we need to plan capacity for our ECS cluster, especially on Spot. So this is a graph which shows memory reservation and CPU reservation. Keep in mind, this is memory and CPU reservation, not utilization. What's the difference? When you create a ECS task, like set of containers, you're specifying how many resources you want to reserve for this container. And even this container going to use, 10 megabytes of memory, you need to reserve for it, for example, 100 megabytes, because maybe sometimes when load increases, it needs 100 megabytes. So what reservation makes sure that container will be put on the instance with the available capacity that you set. So for ECS and for Spot instance especially, we need to reserve capacity. And my advice to keep the reserved capacity always at 70–80%. Basically, it means that we're going to have instances loaded with our containers with 70 or 80%, while keeping 30 or 20% available. Why? There are 2 reasons for that. Even without Spot, probably you want to do safe deployment of new application, like rolling deployments or immutable deployments. And in order to do that, you need to be able to place 2 copies of the same application on your cluster. And for example, you're running 10 copies of application A version 1, then you're deploying application A version 2, and it's going to keep the version 1 at the same time and version 2 at the same time, but you need to have capacity, even for 5 minutes, you need to have capacity on your cluster to keep the both versions. So you need free capacity on your cluster to do that. And the second reason for the Spot instances, as you remember, as I said, AWS could take your instance from you anytime. So you need to make sure that you have some available capacity to move your containers from the instance that died. So for example, you had 10 instances, and you are running a lot of applications there, and one of these instances are being taken out by EC2 Spot. So basically, all the containers that was running there died, and they need to be placed on the new instance. In order not to lose time to wait for a new instance to be created, we can keep some spare capacity just to have this place to move them. But this number is, you can achieve it with target scaling on AWS. So basically, you configure the scaling policy on an auto-scaling group to keep your usage on 70 or 80%, and it will do automatically tracking. Do you need to create more instances, or you can delete some? Yes, but this number, 70, 80%, it really depends on your application. Like in our case, all of our backend written in Golang in very small services, most of them using 200 megabytes of RAM and the same of CPU shares. So we can afford to keep it only 80% on any instance types, basically. But for example, if you have a Java application which needs for startup 4 gigabytes of RAM, of course, this 80% could be not enough. If 80% of total capacity of your cluster is less than 4 gigabytes of memory, then probably this application is not going to be able to start on that cluster. So you need to actually calculate this number by yourself to make sure that your application will be able to fit on this 20%. Okay, let's go further. The interruptions. Look, as I said, interruption is when the EC2 takes the server from you. How ECS can help us with the interruptions? As you can see, this is me. And this is a Lambda I developed. Basically, this Lambda keeps track of multiple things. It tracks for auto-scaling groups hooks. Basically, when you change, when auto-scaling happens, if it tracks for these events, and before terminating instances, it's trying to move container safely from the instance that's going to be terminated to the new instances before the termination actually happens. This is a nice feature of ECS. I believe Kubernetes has it as well. It's called node drain. So you can say to the node 1, drain, and it will just simply safely move all the containers from the node 1 and put it wherever available capacity except node 1. So how does it work? It listens for the events from auto-scaling group or from the Spot interruption event. As I said before, AWS will notify you 2 minutes before interrupting the server. But this notification happens when it not arrives, but usually it does. So this Lambda listens for the interruption event, and it has 2 minutes to drain the server and safely move all the containers to other servers before terminating this one. This helps to basically gracefully stop application without any downtime, because if this copy of application was handling requests and it dies unexpectedly, you will have some errors. But recently, the people who read AWS blog probably know this guy. It's a Jeff Barr. This is a person probably who wrote 80% of all posts on AWS blog. Just a month ago, they introduced native ECS Spot instance drain, which makes me sad because I loved my Lambda. So, but it still has additional functions like auto-scaling group events handling. But if you just want to integrate ECS with Spot, you can do it natively, but basically by clicking checkbox on UI, I think now. So maybe you don't need this and you can do native stuff. Okay, what about stateful application? So as I said, our application could go down any moment. And that's fine if our application builds this way, that it can go down any moment, keeping state in the external database, Redis, whatever. But what if our application is stateless and it saves something on the hard drive, and this instance being terminated and all this data being lost? There's actually tools for that. This is RexRay. Here is the link for documentation. So RexRay is a tool as well as available as Docker plugin, and it helps you to handle Docker volumes as AWS volumes. Basically, I think Kubernetes has this native feature to be able to mount EBS volume for AWS into the container, the external volume. So when container dies, all the data stays on this volume. ECS doesn't have this feature, but you can still use Docker plugins. And this is a plugin which does exactly that. It was developed by VMware. It has a lot of stars on GitHub. It's really easy to install, just Docker plugin install X-Ray on all your nodes in the cluster. It supports EBS and EFS. So EBS is virtual disks, and EFS is virtual file system, network file system, that you can mount into multiple applications at the same time. So what it actually does, is that when you're creating the application, you can say that use Docker volume from EBS, and X-Ray will create the EBS volume on AWS for you, and will mount into the container. When container being killed, it will remount the volume, and when new container started, it will take the same volume and mount it back. So this means that even if application died, all the data that was on this volume stayed alive. There is limitations, because if you know AWS well, they have availability zones, and the EBS volumes are tied to the availability zone. So basically, if you had volume into the availability zone A, and your container was running there, then your container was killed and was placed into availability zone B, this volume cannot be moved into different availability zones. Because that's actually pretty logical, because on AWS level, each availability zone is a data center. For example, if you take Frankfurt region in AWS, they have 3 availability zones, if I remember right, and each of them is a separate data center, which could be located, I don't know, 20 kilometers once from each other. So it's not that easy to move volume fast from one availability zone to a different one. The X-Ray tool is stable, it works fine, it does its job, but it has drawbacks. Recently it started having like really low GitHub activity. It looks like VMware not really maintaining it actively. When I started using it a year ago, it was still active, but the last commit and release happened in January, so there was like 7 months or 9 months without any commits. So, and there are tons of unmanaged pull requests and unsolved issues. But it is stable, you can use it. But if you found some bug, probably you would need to fix it yourself. But even if you do fix it yourself, there's no guarantee that your pull request will be merged, because they don't really seem to be active there. However, it's a really good tool. And there are a couple other ones. There are paid ones, there are free ones, but I found this one probably is the best yet. But also one more problem there, documentation is a lack of examples, and it could be also a bit outdated, so you need to figure out yourself. And the X-Ray iOS side doesn't work anymore. This is also not a good sign. But the documentation one, the X-Ray reads the docs still active. And this is example of using X-Ray in cloud formation. So this is definition of our ECS task. And just here in volumes, we say auto provision true, X-Ray EBS, and size is a parameter type, SSD disk, and 20 gigabytes. And X-Ray will create the volume for you automatically. And in container definition, you just do the mount, and mount this name of this volume somewhere into /date. And that's it for the information. There's actually a project which I recently open sourced, and it uses most of this feature I was talking about. The instances draining, the spot, the parameters, whatever, the external volumes, X-Ray, it's all used in this project. So if you're looking for examples, you can just take a look here and copy paste it, and you can put a star on this on GitHub. I would appreciate that. But that's it. You can ask your questions. And no questions means that it was a really good talk or a really bad one. Oh, I can see a hand.
Yes, so my question is, do you have any experience with GPU in that case? Can you also do this for GPU usage?
Not really. I've seen the releases with the ECS support of GPU, but we are not using GPUs in our processing, so no. Probably not. I think I will hear you and I can repeat your question so everybody.
Did you ever tested the cloud store plugin for Docker? We are using it in production. It does the same which you have explained for the X-ray plugin.
I missed the part cloud what?
Cloud store.
No, I'm not sure what's that.
It's doing the same thing like the plugin you have mentioned.
Okay. I will take a look. Thank you.
It does exactly the same thing and it's directly provided by Docker.
Okay. I will check. Thank you. And you had a question?
How much cost did you save by switching to Spot instances?
Okay, I just will repeat the question. How much Spot cost was saved by switching to Spot instances? I cannot say a direct number, but I can say that we saved also a lot of time because we were using the reserved instances before. And with reserved instances, you reserve the capacity of specific instance type for use for a year or 3. And we were spending a lot of time to plan the capacity for next year. And we were spending a lot of time to keep to the usage of the reserved instances. Because, like, for example, I could reserve the M5 large, but somebody else started M4 large. And that means that we are paying for M5 large and M4 large. So we were also spending a lot of time to make sure that we are using what we reserved. And reserved give us savings of 50% or something like that. And with Spot we get it 70. And I don't have the complete number. But what I can say is that we stopped caring about these 2 instances. Now the piece of complete billing of EC2 instances is that small that most of our costs take is database, caches, Redshift, all this stuff. And EC2 instances, basically we cannot get them even more cheaper than we have in right now. So we don't really care about how much we spend for EC2 because nothing could be done more. Basically, yeah, it could be done. We could, I don't know, optimize a bit our source claims for these CS tasks to keep our clusters smaller. But if it's going to be 1 or 2 instances, it doesn't really care anymore because we couldn't pay less than we're paying now for EC2. Now we have different problems like huge RDS database. Okay, one more?
What are the boundaries of the solution, like using ECS? I mean, what size is how many containers do fit in your ECS setup, and how much could you scale right now without doing anything?
Basically, endlessly. Like our ECS cluster is just the amount of nodes that we have in the cluster. So if I change in my autoscaling group from 15 that we have now to 100, it will scale. And if you create all the Spot instances for 100 Spot instances. Or now, like so as I said, our all backend written in Golang, and we have pretty small containers. And we have currently we're using for the Spot cluster mostly T2 and T3 medium instances. We have kind of 15 right now, and we are running like 50 containers there. But it's not a problem to scale at any moment. I just change the one number and it goes. Any other questions? Okay, go ahead.
I can see this being helpful if you have a containerized application. Would you recommend it for a classic LAMP stack, like a stateful application?
Not that much. It depends on your application. Even if your application are running on EC2, but it's pretty stateless and it can afford being interrupted, then yes. But if it generates much more problems by handling states and and keep replacing the servers, then probably not. Even with these plugins, it's really cool. It can take the volume and mount it back with all the data, but it has limitation regarding the availability zones. So if your server being launched into different availability zones, then volume cannot be mounted from the old one, and it could generate problems. But we are using this for Neo4j. For one who knows, Neo4j is a graph database, and just recently launched in production, like for 3 months. I've been developing this for a long time, and now it's basically a solution that we're running in production. It's running on DCS and on Spot, and it's basically a database. It's database on Spot, but it works pretty well. Like it has 3 nodes minimum, and it can survive failure of one. So if Spot terminates one node, it's still a healthy cluster, and it will take 1 minute to create one. It will join back, and the cluster is safe. Okay.
So how do you get around the limitation if the volume is in one availability zone and your instance is launched in another?
It depends. For our main cluster of microservices, we don't care because we don't really have anything written to the disk. So there we don't. But for Neo4j, I can open the link. Neo4j, a couple of our different applications that we have. We have an application which writes analytics to the disk and then uploads it somewhere. So here I have a diagram. So basically here I'm saying that limitations that you have could have only the same amount of nodes as availability zones. So basically for this setup from Neo4j, we are having 3 nodes in the cluster. Each of the nodes launched in different availability zones, and we limit it to be placed only like this. So if one of the nodes dies in availability zone A, it will restart in the same availability zone and reuse the same volume. That's not very flexible because if you want to scale more, or for example have a cluster of 9 instances and there are no 9 availability zones, you can scale with read replicas because they don't use the volumes, but the core cluster could have as many nodes as availability zones in the region. For US East it's 6, but for different regions it's usually 3. So that's the big limitation, but it's kind of fine for now. Any other? Nope, seems not. Thank you. As far as I know, you can rate the talk somewhere on website, so please go and do that. And thank you for your attention.